Hello class, today we are starting chapter 9, which is focusing on quadratic and exponential functions. Today's lesson will focus on quadratic functions and how we can graph them. By the end of the lesson, you'll be able to graph using a table, identify the characteristics from a graph, find the maximum and minimums using the graph or the equation, and then graph the quadratics using those characteristics that you are able to identify. First thing that is helpful for us to know is a quadratic function is a nonlinear function written in the form f of x is equal to ax squared plus bx plus c, where a is not equal to 0. Ax squared plus bx plus c should look familiar to you from last chapter. That is one of the equations that we were factoring. Now we're working more with it and how we graph it. A parabola, that is what we use to describe the shape of a quadratic function. If you look at those two blue shapes down at the bottom, both of those are parabolas. That is how a quadratic function looks when graphed. A minimum is the lowest point on the graph of a parabola if it is opening upwards. So that U shape means that it's opening up. That green dot at the bottom is the minimum. This happens when a is greater than 0, aka a is positive. A maximum occurs in the opposite situation, the highest point on the parabola, again that green dot at the top of that example parabola, occurs when a is less than 0, aka negative. Other vocab that we have here is the axis of symmetry. So that's the central line in the parabola. If you notice back on that last slide and both in this graph down here, parabolas are symmetrical, meaning if we folded them in half, the two sides would line up. The line that we are folding on is that axis of symmetry, and the equation to find that is x is equal to negative b over 2 times a. So if you look at that graph down in the bottom right-hand corner, that red vertical line is the axis of symmetry. It's an x equals equation because it is a vertical line. The vertex is the general term for the maximum and minimum. So that vertex point is either going to be your minimum point or your maximum point, and that is the place where the parabola intersects the axis of symmetry. So that high point or low point is always going to be touching the axis of symmetry. So the first thing we're going to do here is graph using a table. So we've got our equation y is equal to x squared plus 6x minus 2. So we need an xy table, and we are going to start with our regular values of negative 2, negative 1, 0, 1, and 2. Those are the 5 simplest numbers that you could use to put into a graph. What this is asking you to do is say y is equal to negative 2 squared plus 6 times negative 2 minus 2. Remember, when you are putting this into the calculator, it is crucial that you keep those negatives in parentheses. So make sure when you are typing that into the calculator that the negatives have parentheses around them. When you plug this into the calculator for your first answer, when you plug in negative 2, we get an answer of negative 10. When I plug in negative 1, I get negative 7. 0, I get an answer of negative 2. 1, I get an answer of 5, and 4, I get an answer of 14. So I'm going to go ahead and put these on the graph. Since my largest value does not fit on the graph, I'm going to go ahead and change the numbering. I'm going to go up by 2's. Since I have negative values, that means I also need to change the bottom, so we're going to go down by negative 2's as well. If you change the top of the graph, you have to change the bottom of the graph. Same with left and right if you were to renumber the x-axis instead of this y-axis that we're looking at here. So now I'm going to go ahead and graph my points. I start at negative 2, negative 10. My next point is at negative 1, negative 7. Then I have 0, negative 2, 1, 5, and 2, 14. So if you notice, we don't have that complete U shape yet. It looks like we've got a little bit of a curve going on here down towards the bottom, but we don't have that complete U shape. So what that means is we're going to have to add on points. Since it's getting closer together, aka curving more at the bottom, I'm going to add on more negative numbers. It was curving more at the top or getting closer together at the top, then I would add on more positive numbers. So I'm now going to plug in -3. When I do that, I get an answer of -11. So that's the next point on my graph. I'm going to go down -3, -11. Still haven't started to go back up to complete that U shape, so I'm going to plug in -4. When I plug in -4, I get an answer of -10. So I'm starting to come back up, -10. So I'm starting to curve back up. As I said earlier, parabolas are symmetric, so I can now just trace across using symmetry to use that complete U shape. So every time I go over one, I'm going to go to that next point. Over one, to that next point, over one, to that next point. Then the last thing we need to do is connect all of these dots. Make sure it is a smooth curve. It should not look like one side with a point on the other side. It should curve and look like a U shape. Personally, I find it easier to draw a left and then a right, or a right and then a left, one half at a time. If you want to do the complete curve all at once, that is okay. Last thing we need to do is state the domain and range. If you recall, the domain is all of our x values. So this is any numbers that we can plug in for x. Since we can plug in anything for x, we're going to call this all reals, or you can use the shorthand abbreviation of a capital R with a line through it. Either of those are acceptable. Looking at our range, those are our y values. So if we are looking at this graph, it is curving at the bottom and it reaches a bottom point. If you notice, if we kept our table going, no point can be lower than -11, so that means y has to be greater than or equal to -11. If the parabola was flipped over and had a maximum, then it would be y is less than that maximum y value. Go ahead and try this one on your own, graphing by making a table and then stating the domain and range. So that table, we've got -2, 11, -1, 6, 0, 3, 2, 1, 2, and 2, 3. This one starts curving on its own without having to add in any extra values. So as you can see, we went through and finished that parabola using the symmetry values. Domain, again, is all real numbers, and range is y is greater than or equal to 2. All of the numbers for y are greater than or equal to 2. Next thing we're going to do is they graph it for us, and we need to be able to identify the characteristics of that graph. So first is finding that axis of symmetry. We're looking for where the parabola could be cut in half, and that is, in this case, x is equal to -1. We're on the x, and we're at a -1. Next thing we need to do is find the vertex. So that's that, in this case, low point on the graph. So in this case, our vertex is going to be at -1, 0. And the last important characteristic is the y-intercept. So where we are on this y-axis line. In this case, we are at 0, 1. So 3 values to pick out from the graph: the middle line, the vertex point, and the y-axis point. Go ahead and try this one on your own. That axis of symmetry is that x is equal to 2, vertex is at 2, 3, and the y-intercept is at 0, -1. We can also identify these characteristics based off an equation using the formula that we were given for the axis of symmetry. So our formula from slide 1 for the axis of symmetry was x is equal to -b over 2a. Looking at our equation up top, we have a value for a, we have a value for b, and we have a value for c. So in order to find the x, we're going to start by taking the negative, or the opposite of this b value. So x is equal to, since we had a +4 to start, it's going to be negative in the equation. Then on the bottom, we have 2 times our a value, which in this case is 2. So my equation is now saying -4 divided by 4, giving me x is equal to -1. That is the axis of symmetry. Since we know that the vertex is on the axis of symmetry, we can go ahead and plug that x value in to find the y value. So I would say y is equal to 2 times negative 1 squared plus 4 times negative 1 minus 3. Following PEMDAS, the first thing you do is square. So I've got y is equal to 2 times 1 plus 4 times negative 1 minus 3. Then I'm going to go ahead and do the multiplication. So 2 times 1 is 2. Negative 4 times negative 1 is negative 4. And then minus 3. So to finish the problem, I have 2 minus 4, which is negative 2, minus 3 gives me negative 5. So that means my vertex point has an x-coordinate of negative 1 and a y-coordinate of negative 5. The y-intercept is very simple. You're going to take the formula 0, comma, c. So whatever that c value is, we use for our y-intercept. So I've got 0, comma, negative 3. So we found our axis of symmetry using the equation x is equal to negative b over 2a. We plugged that value in for x to find the y value of the vertex, giving us negative 1, negative 5. And the formula for the y-intercept is 0, comma, c. So in this case, 0, comma, negative 3. Go ahead and try this one on your own. Negative b over 2a results in 3. When I plug in 3, I end up with a y value of 13. So 313, and then for my y-intercept, 0, comma, c gives me 0, 4. Maximums and minimums are similar to finding that vertex. We just have to decide if it is a maximum or minimum. If you look back on that first slide, minimum means a is positive. Maximum means a is negative. So if we're looking at our a, b, and c values here, our a value is 2, b is negative 4, and c is negative 1. So since my a value is positive, I'm going to have a minimum. You find the value of the maximum or the minimum the exact same way you find the vertex. So the first thing we need to do is negative b, which in this case is negative 4, over 2 times a. Since I have a negative of a negative 4, that turns positive. So I've got 4 over 4, giving me an answer of x is equal to 1. Then we're going to go ahead and plug that in and say y is equal to 2 times 1 squared minus 4 times 1 minus 1. We start by squaring, which gives me 1, so 2 times 1 minus 4 times 1 minus 1. 2 times 1 is 2. Negative 4 times 1 is negative 4 minus 1. 2 minus 4 gives me negative 2 minus 1 gives me an answer of negative 3. So my minimum is at the point 1, negative 3. For the domain and range, as we discussed earlier, we can plug in anything for x, so our domain for this function is still all real numbers. When it comes to the range, we have to pay attention to the y value of that minimum point. In this case, it's a minimum, so the y's are getting bigger. So it is bigger than or equal to negative 3. Had it been a maximum, we would flip that around and say that y is less than or equal to negative 3. Go ahead and try this one on your own. Because the a value is negative, we have a maximum. Solving for x, we end up with negative 1. Plugging that back in, we end up with an answer of 8 for y, so our maximum is at negative 1, 8. Again, our domain is all real numbers, and since we have a maximum, our y's are less than or equal to 8. Last thing we're going to do today is graph using these characteristics. So the first thing you graph is the axis of symmetry. Then you're going to graph the vertex. Make sure to know if it's a maximum or minimum so you know if your graph is going in the right direction. graph the y-intercept, use symmetry, so use that axis of symmetry to graph the third point, and then the last part is to connect with the smooth line. Alright, so when I am graphing using the characteristics, this is going to simplify the process a little bit because we won't have to plug in so many values for the table. So the first thing you want to do is go ahead and find that x, or that axis of symmetry. So we've got negative b over 2 times a, which gives me negative 4 over negative 4. So my axis of symmetry is x is equal to 1. I'm going to go ahead and plug that in on the graph with a dashed line to show that that's going to be my middle of my graph. And then I'm going to go ahead and plug back in to find y so I can find my vertex. We know that the vertex is going to be a maximum because of that negative 2. So I've got y is equal to negative 2 times 1 squared plus 4 times 1 plus 1. 1 squared is 1, so I've got negative 2 times 1 plus 4 times 1 plus 1, giving me negative 2 plus 4 plus 1. Negative 2 plus 4 is 2 plus 1 gives me y is equal to 3 for a vertex point of 1, 3. So I'm going to go over on my graph and go over 1 and up 3. If for some reason your vertex is not on that axis of symmetry that you drew, that means something has gone wrong with your vertex. The vertex will always be on the axis of symmetry. Next thing we need to graph is that y-intercept using that 0, c format. We've got a point of 0, 1. So I'm going to come over here and put a point at 0, 1. Now, step number 4 was to use that line of symmetry to get a third point. So I'm going to take this y-intercept, go across the axis of symmetry, and put on my next point. So that mirror point that we have to show where the axis of symmetry, if I fold it in half, that's where my next point would be. And then the last thing I need to do is connect them with that smooth curved line. Again, we don't want it to be at a point at the top, we want it to be curved. And the parabola proceeds down from there. Go ahead and try this one on your own. Finding the axis of symmetry, we have negative 4 over 2, which gives us an axis of negative 2. That's that red dashed line. Vertex, we plug in negative 2 and get an answer of negative 1. That's that blue point at the bottom. The y-intercept is 0, 3. That purple point is the reflection point. And then again, the smooth curved connection. If you have questions about this or anything else from the lesson, please let me know when you get to class.